We begin machining the bottom part of the motor mount by modifying an existing stainless steel socket head cap screw. Basically shortening the bolt head so that I can use it to bolt down the plate that I'm machining, and the top of it will actually reside below the surface of the plate. Here you can see the socket head cap screws in the surface of the plate. This cut put quite a bit of strain on the spindle, even at only 2.5 thousandths depth of cut. I also again became painfully aware of the tramming in the y-axis. When the motion is in the y-axis, it kind of has a concave surface to the cut. And then when you have successive cuts where the travel is in the x-axis, but you're stepping over in the y-axis, there can be quite a bit of discrepancy between the two cuts where they meet, usually resulting in a ridge, a fairly pronounced ridge actually. You can hook your fingernail on it, almost about the thickness of a playing card. Let's speed that up a little bit here. You can really make out that wavy surface and the general non-uniformity of the cut here. Not bad, but definitely not in tram. And there's no way to adjust it that I know of other than taking the spindle column off and shimming it. These are just recesses to accept the socket head cap screws. the spindle is definitely canted. I can feel it and hear it when I'm cutting. So I just kind of went all over this thing to make sure the low side of the cutter hit pretty much every spot on there. It feels flat, although you can kind of feel some waviness in it. So I'm going to have to figure out how I can trim this spindle to the table. It's fine in the X, it's the Y. It's if the spindle's straight up and down like this, I can tell it's kind of canted forward like that, to where when it's cutting in this direction, it's the cutter is digging in and the back side is not engaging. So it's, instead of spinning like this, it's kind of like this. I didn't film that last facing operation because it was just done manually. Here I just wanted to show the importance of clearing the chips out of those slots when the coolant would start to fade, it would really crunch and grind those chips, which was obviously very bad for the cutter. One of those socket head cap screws was to hold that piece that I cut out so it wouldn't break away and then chip my carbide end mill. And this operation is just to kind of mill out an area for me to put a temporary clamp. Let's speed this up, shall we? I've placed the clamp and am continuing the rest of the pocket. I almost got into big trouble here because I had assumed that the spindle shaft was centered to the column head, but it was not. It's off about, I don't know, a quarter inch or something to one side, so I had to update that in the model and adjust it in the machining. Here I'm just putting a nice chamfer around all the edges. Here I'm using my 1/8 inch end mill to make some countersunk holes for some 1/4-20 socket head cap screws to bolt this plate to the top of the column head. These also get a slight chamfer. With the bottom part of the mount essentially finished, I ran into an odd problem, and that is I couldn't get the 3/8 inch washers to fit into the slotted holes I made. So I came up with this idea, and that was basically just to bolt a stack of them together and then mill them down to the correct size. I kind of made a mistake in the cam software, you'll see here at the end. It's climb cutting now, but the finish pass was a conventional cut, and you can see how detrimental that was to the surface finish. Pretty rough, but it ended up not being that big of a deal. I just kind of sanded off the burrs and unscrewed the bolt, and then the washers just kind of separated. Here are the two plates together. The top plate slides back and forth on the bottom plate so you can adjust belt tension. Everything worked out great. Very pleased with it. Thanks for watching.